Good afternoon. I'm Kenny. I'm one of the product managers here at Oracle. Now, this talk is about the operator for Kubernetes. Let's see, who's using, maybe a question, right? Why not? Who's using Kubernetes here? Okay, many of them. Who wants to? Maybe. Who does not want to? Why not? Yeah, so we have a MySQL operator for Kubernetes, so I'll be talking a little bit about that. Quite high level, not a lot of time to really go into demos as well here, unfortunately, today. But yeah, I'll have plenty to cover at least. So let's start with MySQL InnoDB cluster for those who were not on my talk earlier today. And I think it's important to talk a bit about it, to see like, okay, MySQL InnoDB cluster, what is it, right? So MySQL InnoDB cluster is our solution where we use different technologies of MySQL, such as MySQL Server, MySQL Group Replication, MySQL Shell, MySQL Router. We use it to make like best practices or architectures where we have a high availability. In this case, with MySQL InnoDB cluster, we have automatic failover, we have automatic node provisioning. We have, basically, we can guarantee consistency, no data loss when there's a failure, and everything. Then we have the router, which is how to access the data. So when the primary moves around, how does the application get to the primary? Well, router takes care of that, and router redirects the traffic to the primary, redirects read traffic to secondaries, however you configure it. So, and then all of this is basically managed through the MySQL shell, which is the interface which you use to configure the group, to configure MySQL router, to configure your architecture. So earlier today I talked about InnoDB cluster set as well, where we have some disaster recovery features and basically solution that helps to really make disaster recovery easy. But this presentation is mostly talking about high availability, especially in relation to the Kubernetes operator. So a little bit more, and I've touched on some of these things, but it's good to recap. So we have guarantee consistency. You can write to multiple nodes at the same time in group replication. That is possible. So we have built-in conflict detection and resolution, so no data loss. Network partition handling is in there, so when one member fails or has network partitioned, a primary will be selected out of the majority partition. So it's using quorum to calculate which one should be the primary, should contain the primary member, and so on. So router does the load balancing, sending the traffic to the right member that is needed, and it does it all transparently to the application, basically. You can deploy router as a separate layer, or you can deploy router on every application server. It's quite lightweight. It's quite stateless as well, because the whole configuration is written to the database, and Shell just updates the configuration, and the routers adapt their configuration online without you having to connect to the router, restart the router, and so on. So there's very little configuration needed in MySQL router. So the router is integrated into InnoDB cluster, InnoDB replica set, InnoDB cluster set, and so on. Then we have the shell, which is our interface that provides JavaScript and Python interface, as well as the SQL interface. And it can connect using the classic MySQL protocol or also the X protocol. You can do the document store, which is also available through the MySQL shell. So there's a lot of features that MySQL shell has. Other features are like a logical dump and load, which is like a multi-threaded dump, multi-threaded load tool as well. There's a whole set of tools available basically in Shell that help you as a DBA to optimize things or to troubleshoot things. There's also plugins you can write for Shell, so it's quite extensible. You can write your own plugins. We have some people in a community team that write plugins regularly on just automating more things in MySQL. Now, if we talk about Kubernetes, and Kubernetes, I'm trying to kind of make a correlation between the two, because MySQL InnoDB cluster, if I go back, and Shell, everything is built around making things easy to configure. It's really simple. It's all fully integrated. And everything is basically, we have a lot of customers using MySQL InnoDB cluster like large and small, basically, wide deployments here. Really makes it easy. And I think with Kubernetes, the goal is also to kind of provide a platform to configure and automate services, to make services. I wouldn't say that MySQL InnoDB cluster is exactly the same, but in Kubernetes, it tries to configure containers. And an operator in Kubernetes is basically a method of creating a service and deploying that service and providing all the features that you need that you would need, for example, for a database. So what do you want? You want an operator to configure the cluster, the database, the access to the database, to provide backup and restore functionality, to have monitoring built in, to be self-healing. And MySQL InnoDB cluster by default does have high availability, has a lot of things that it has built in. But maybe an operator is even more. It provides even more healing opportunities that maybe MySQL InnoDB cluster doesn't have. And it does, right? Our operator. So the operator is a way to declare, like, I want this type of service. I want to run a database, MySQL service. I want it to be like this, that many router nodes, that many server nodes. Well, I can see that you can see both Kubernetes operator and MySQL InnoDB cluster, they try to make it easy for you to deploy and manage a service, basically, a database, for example. So we have our operator for Kubernetes that we've released, I think it's like more than a year ago, maybe 2 years ago almost, where we have made one here, developed by the same team. We're built by the same team at Oracle that develops MySQL InnoDB cluster as well. So it's the same engineers, same architects working on this. And what they did is they took MySQL InnoDB cluster that our customers use and made some extensions on top of that so that it also works as an operator in Kubernetes. So the good thing is that we are eating our own dog food as well, similar to how we have the MySQL database service where we run MySQL, we have to maintain MySQL. Well, if you are in a kind of want to have a run on Kubernetes, it's the same thing. The same InnoDB cluster is being used, group replication is being used. It is not yet another product. It's something built on top of MySQL InnoDB cluster. So it's using all these commands from MySQL InnoDB cluster to say add instance, to do clone, to set the primary, to configure router and the metadata. The operator just automates an extra part of this. So what does it do? It makes sure that failover happens. It provisions the nodes, adds more containers. You can say in the operator, let's add more nodes. I want more router nodes, things like that. And the operator will do so by using MySQL shell or MySQL InnoDB cluster. Even the things that it does extra, the operator, is that when an instance fails and if I go back a little bit, an instance fails here in group application, one fails, well, you need to provision a new member here. So what do you need to do? If you run regular MySQL InnoDB cluster, you have to fix this node or add a new node. Well, what the operator does is if this one fails, it can just spin up a new container and it will add it back to the cluster again. So while high availability is done by group application, there's a lot of extra things that the operator can do to make sure that the database stays healthy, and in the event of a failure, which will happen at some point, it automatically recovers as well and adds new resources and so on. So it does a lot of extra steps. If the whole power fails, for example, here, like everything dies, like there's a big power failure, everything's down, everything comes up. You have to do a manual operation in InnoDB cluster to basically kind of reboot from outage. Well, in the operator, if that happens, the operator will just do that for you, so you don't have to do anything. Let me go back to the slides. So yeah, it replaces instances when one fails, recovers when everything is offline. Also, when there's a majority loss, let's say you have 3 members and 2 of them go away, the operator can see, okay, what happened to those? Are they gone? Is the process gone? And can I recover from it? And normally, with regular MySQL InnoDB cluster, you would have to figure out, okay, what do I do? Can I add new members, or should I recover the other ones? Well, when the operator knows that there's no data loss, what it will do is it will recover, and it will add new instances again. It will promote the minority partition, so the ones with to become majority, and just force the cluster to come online again. So again, more steps that the operator can do because it has insight in the hardware that it's running, the containers that it's running. It can kill containers, all these things, which regular group application, it cannot do it the same way. The operator also has logical backup and recovery built in. So that means that you can say take backups regularly, recover from a backup. So you have a restore as well. So you can spin up a new MySQL service and then say restore from this snapshot. And this is using MySQL shell logical dump and load. It's logical, but MySQL shell is actually quite fast in dumping data, but also in restoring. There's a couple of steps that it takes. Like, for example, you can speed up logical restore with shell in parallel by, for example, disabling the bin log. Disabling the redo log will make it really a lot faster. Depending on the hardware and the kind of the schema that you use, we've seen rates up to 900 megabytes of logical data loading per second. You need to have some higher end server, of course. You need like 50 cores, something like that. But it can do it. So physical snapshot is, of course, faster, but yet that feature is not yet available in our operator. So what do we guarantee with the operator? We guarantee that there's no data loss, RPO 0, if a primary fails or another member fails. We prevent split brain using quorum. We have automatic failover in the event this failure happens. Automatic network partition handling. You can add and remove members as you want. You can have up to 9 members in InnoDB cluster, and you can use those 9 members as read scale out. So every member in the group has a full copy of the data set. So it's not like a scale out solution. That's not what MySQL InnoDB cluster is. But every member has the full data set, but you can use it to do a read scale out. If you have, so there's also a lot of users have read replicas that they use asynchronously, so replicating asynchronously, but then you have eventual consistency. So it is possible that if you read from a read replica, that you don't read the absolute latest data because replication is asynchronous. Now, if you use a secondary member in the group for your read traffic, you can actually enable full consistency. So you can say, I want to read absolutely the latest data. Even though you're a secondary, I want to make sure that I read everything that has been committed so far within the group. So you can enable full consistency. There's a lot of settings available. There's a couple of, like 3 or 4 settings available that you can tune per query, per session, globally, and so on. All of this requires a MySQL 8. And InnoDB cluster is supported with MySQL 5.7 and 8.0. But for the operator, we really need 8. And why do we need 8.0? Well, there's a lot of features that we added in 8 to really make it easier to run on containers. Things like clone plugin. You don't have to take a physical snapshot by SSHing it into a machine, taking a snapshot, copying back. It doesn't make sense within a containerized environment. With Clone plugin, you spin up a container with MySQL, you connect to it using MySQL authentication, and you say clone from the other machine. And that's all you need to do, and it will provision itself. It will take a physical snapshot, it will do what it's needed to basically get that to a consistent point, because it is an online snapshot happening. So there's a donor, so the one that you want to copy it from, happens online, so it recovers this into the machine that you want to provision. So that's great for these types of environments in Kubernetes. We have set persist. No need to go and edit the my.cnf. The shell doesn't need to do it. The operator doesn't need to do it. Everything can happen over a MySQL connection. The same with restart. It's a simple command, restart. We didn't have it until 8.0, but it allows you to restart the database. And we need this so when the clone performs a snapshot, you can then restart it and bring it back with all the data that it had. Other features such as the performance schema error log, small feature but yet quite easy to use, makes it really easy to use. You don't need to access the machine to see the logs. You can see the logs from within an SQL session. And MySQL shell can actually query that. If we don't have the error log table, then how can shell read something from a remote server? It would have to SSH, and we don't want to do that, of course. So you cannot do a remote login. So bringing it in the error log really helps. It's small things, but all these help the user experience, not only for you, but also for our automation. We can start automating things. We can read errors. The operator can read the error log and see if there's any errors and automatically recover based on that. So that brings a lot of possibilities. Another thing quite important for us is that in 8.0.19, quite a while ago, I think in 2020, early 2020, we implemented DNS SRV records in our connectors. And that is used in Kubernetes a lot to do service discovery. So what DNS SRV is basically in Kubernetes, the nodes of the database will register with etcd, which is often in Kubernetes used. And then that provides information to etcd to be able to do DNS SRV requests. And then you can configure your application to connect to a service, the service that you named in Kubernetes, and then it will find it. And then automatically the connectors will using these DNS SRV records, it can find the primary, but it can also find all their secondaries. DNS SRV allows for priorities. It can have multiple servers that it returns based on weight and priority. There's some settings there. And yeah, that makes it, again, much easier to use to deploy in Kubernetes. Other work we've done for this is that we had to update our container images. We had some for a while, but we had to make changes for it to work better in wide range of kind of Kubernetes flavors or deployments, like supporting random user IDs. Some, like OpenShift requires random user IDs, while here we have that. The restart capability. If you do not use our Docker containers or our containers, and you use the one that Docker provides, you don't have the clone support or restart capability. It is easily fixable, but they haven't. We have fixed it because we need it. We need to be able to have the restart and clone support. So you use our containers, and they're available on the container registry, .oracle.com, both community and commercial versions of it. And then we also made a router container. It wasn't GA yet, so we recently made this GA as well because we use it in our Kubernetes operator. So how does it look like? Nothing out of the ordinary. Basically, we have an operator container running, which is the operator, which is basically MySQL shell. And MySQL shell runs and does its work to be able to deploy a MySQL server with primary, multiple secondaries. It provides the volume. It configures group replication, MySQL InnoDB cluster. It also configures the routers. You can scale them up and down online as you want. The operator will do all these tasks for you, and it will recover from those scenarios where the InnoDB cluster cannot recover from. So you can configure your application pods to connect to DNS SRV to find out where the MySQL service is. And there's a load balancer that we use in between, just a load balancer available to be able to redirect the traffic to the necessary routers. But if you use DNS SRV, you don't have to use this load balancer. You can go directly, because DNS SRV will know about all the routers and provide that back to the application. Next to it, there's some sidecars on backup jobs for backup and restore, which can upload backups to. So we have OCI object storage support. We have S3 support as well. And yeah, or local disk. That's where you can send your logical snapshots to. So S3 is also something that we've added. And you interface, you don't do MySQL InnoDB cluster commands yourself. You just use kubectl, of course, if you're using Kubernetes, quite familiar, to control and declare what the state should be for your services with the operator. Right now, as it is, we are kind of a level 3 maturity operator. So there's like 5 levels that are kind of defined in the operator framework. We do the full life cycle. So we do the installation, we do the upgrades, rolling upgrades, where we update the secondaries first, and then we make a secondary the primary, and then we can upgrade the last one. So the upgrades are fully handled. It does the patching, then the backup, recovery from failure. So it's a level 3. So we're not yet at level 4, where there's integration, full integration with monitoring, alerting, log processing, and all this, which relies a lot on external, like whatever services are available. So of course we look at the CNCF to see like what services are most used, of course, to be able to provide that. But right now we're level 3. So it deploys server, group application, router, self-healing. I think we've covered that. So S3 and object storage so far, OCI object storage, rolling upgrades, configuration management in there as well. You can configure what the configuration should be, and then the operator will control that for you. You can also launch a new database or a new service by using a clone, and say you get your snapshot from somewhere else and create a new cluster out of that. Of course, you can use your own registry, so you can copy the images available on the container registry from Oracle, have your own private ones. If you deploy a lot of them, it's good to have them local. This works for both community and enterprise editions of our MySQL, so MySQL Server, Community, and Enterprise. And we do integrate several enterprise features. So if you use MySQL Enterprise, what will you have automatically if you deploy using the operator? It will see you're using Enterprise, and it will start enabling the enterprise features. And what we have so far is data masking, encryption functions, and keyring functions. And it will make sure every node has it activated, up and running. More of these will come, of course, as we update releases. So all of this is fully made by the same teams at Oracle, fully supported by Oracle. So yeah, I think that's my talk, kind of right at 20-25 minutes. Please rate my session here, and I am here to answer any questions you might have for a couple of minutes.